Hello everybody, welcome back to From Rhythm to Algorithm Part 35, Interactions and Intersections. Picking back up where we left off last episode, trying to find more physical reasons for mathematical relationships. We've talked a lot about basis and range. What we've proven physically is that basis is finite. There's one basis, there's a finite amount of elements in that basis, and now I don't know how. We'll just talk about the ideas I don't know. So the first thing I want to do is I wanted to start off with a physical demonstration. We've proven and shown the inconsistencies of mathematical theory or mathematical representations, but, well, I have a beer, I don't have water, but if you go put ice into water, what's going to happen? The ice is going to float. So anytime you have a correct natural definition, I've talked a lot about natural definitions and deriving the definition of sensorality, but it requires no explanations and it requires no exceptions, right? If you say, right, I before E except after C, we've talked about that in this lecture series. Anytime you describe a physical law, a physical principle, a physical relationship correctly, there's none of the exceptions. It's just you say it one time, people get it, they understand it, it's agreed upon, the end. Conversely, anytime people don't know, or there isn't an accepted convergent solution or accepted explanation, that's almost certainly incorrect. We've proven that the basis of physics is finite. What exactly it is, how we articulate it, that's where I'm still a little, again, sorting things out. I've already proven these things, and I'm making these statements more general, literally syllable by syllable. So, solid versus liquid versus gas. Solid and liquids have definitive volumes. Gas does not. So we've talked a lot about the fundamental stability of two, so we'll just make a physical conjecture saying that gas is not a correct representation of what matter is, because it's not a dependent system. The molecules of a gas are just flying away from one another. They're not coherent, they're not rhythmic, they're not working together. Again, don't know what to do past that, but like I said, ice floating in water is a physical demonstration of inconsistency of density, of physical categorization, of the basis of thermodynamics, the basis of physics, the basis of size. And so, now, just reviewing the one-way, time-dependent evolution of the universe, what is the relationship? The relationship of the fundamental stability of two, 5 elements and sets, 7 numbers, iteration, and factorials. Factorials, again, just Google it if you don't know, but any number n written with the exclamation sign means to take n minus 1, multiplied by that number, multiplied by, right, I forget the general form, but n times n minus 1 times n minus 2, all the way till 0, or to 1, actually, not to 0. But why physically? That should be a physical process. That should be some, like I think, nothing, right there, 0 is nothing, the set of nothing. You have vibration with dimensionality is rank. In mathematics, you'll have rank or cardinality. The correct term for that question is rank. You have nothing, then you have vibration. Vibration has temperature. Then you have differentiation and stability. Then you have light with 2. And then you have differentiation plus stability equals 3 matter. In the rank, the physical dimensionalities of these things are the words for the physical properties, right? Vibration has temperature. Light, this is where I get hung up right now today, right? Structured physics, E equals h nu. Frequency, so light is a function of frequency. It has energy. The two-dimensional components are energy and frequency. And then matter is momentum for sure, frequency, vibration, temperature. He said, I don't know, all right, 2 is not a number, there's no 2 anything. We've proven there are no closed systems. I can eat a cheeseburger, I'm going to change my mass structure. So what does 2 pair to? What does 5 pair to? I'm thinking it's elements or sets or categorizations. I think there's 7 numbers. I think multiplicity is iteration from those 5 sets, 7 numbers, right? Like Pascal's triangle. I've seen that on the internet a bunch recently. That's certainly just some, right? So you start with 1, you build a pyramid. The jumps, those can be iterations or just like discrete something. But the reason, the motivation, why does that occur? Why does that happen? It's some sort of formalization of iteration. What do mathematical savants do? I'm 100% confident they are aware of the fundamental iteration of numbers, right? They're not sitting there calculating the ratio of pi from circumference to radius or something like that. They're literally aware of there's an iteration of numbers, of letters. Clearly, I don't know what it is, but that's what savants and people like that are doing. But I wanted to ask why, what physical reason do factorials exist for? Still trying to get a handle on the mathematics, the number fields, the 7, 5, 2, what's the difference? And light throws me, right? Now forget this, forget the math, the logic. Light has no momentum. Light is not moving. So frequency. So does light have temperature? Don't know. What is the relationship of temperature and light? Why do I have a better understanding of vibration and matter than light? What's the hang up here for me right now? But what are the use cases of integers versus prime numbers? I think personally, like integers, like 1 marker, 2 beers, 3 beers, 4 beers. I think prime numbers are going to be the location points of the valence shells, some sort of, again, iteration, Pauli exclusion filling shells, or resonance versus deconstructing resonance. I think that's why do we care about prime numbers at all, besides the irreducibilities? I think physically it's because of valence shell locations. But I just wanted to point out, right, we talked about 2 to the 3rd, but now we've proven physically 2 is not actually the basis. These are phase changes. So how about, right, 2 to the 3rd equals 8, that's 7 elements. 3 to the 2nd is 9, and it also has 7 elements. So I'm thinking this is like the time dependent, this is the time independent, or only for 3 dimensions or something. But again, what's the general relationship of base to exponent? And how fast does f of x grow because of the relationship of base to exponent? Right? 2 to the 3 is 8, 3 to the 2 is 9. But if you start growing the base pairs in the exponents, the difference gets bigger. So what's the iteration function of exponents to base? I don't know, thinking out loud. Let me start over. So now, again, just like I said, these are stuff I've already derived. And the amount of logic that goes into this, like, so I'm not sitting here like consciously cycling through theorems. It's just so intuitive at the higher levels. But I don't know. I've proven things about light, so I don't know what that word means. I don't know what the physics is, right? If I said how is light not moving? It's one background, one cosmological microwave background. That's temperature. That's our vibration. So how do these physical properties stabilize? What exactly is that relation to numbers? Missing it right now. But dimensionality is rank. Talked about that. Syllability of rank 5. Speciality, special, with ity at the end. We should be able to take these physical and mathematical arguments and improve our statement of preservation of pronunciation, right? Speciality and sensorality have 5 syllables, so I think we should be able to take, again, either 5 elements or 7 numbers and say, like, a complete general word, the most general word of a word family is 5 syllables or 7 syllables. The iteration, I think that's
where prime numbers come into play for systems of, 100 million, 500 million, X amount of billion data points, and that's multiplicity. Remember, infinity is the physical concept of counting up, and general size being too larger than you can get to physically. But we should be able to make some rank statement about syllability. And now I just want to finish up with this lecture series by proving these things. Proving these things are unknown. What am I proving? That they're unknown. How many senses do we have? Direct physical question, yes or no? Yes. So if you Google it, nobody knows. There's not a proven correct answer to how many senses do we have. Sensorality, senses. The common denominator is common sense. So how many senses do we have? All right, if you Google it, they'll say 5 basic senses. You have taste, touch, smell, sound, and sight. Taste. If a molecule touches your tongue. Touch. I like that one. Smell. If a molecule touches your nose. Sound. If vibration touches your eardrum. Sight. I think we have 2 senses. I think we touch things and I think we see things. That's it. Touch and sight. And so, what's the difference? I think, right, light, sight, seeing light, sight is light, sight perceives light. So we should be able to draw a direct physical consequence from the word sight, from differentiating sight, from differentiating light. And numerically, that IGH, that's the same as 8. A-I-G-H-T. E-I-G-H-T. I mess up the vowels when I'm switching languages quite a bit. But my point is there is a set amount of numbers. We've proven that the basis of vibration is finite. The basis of dimensionality 3 is finite. So this has a correct answer. And I'm pretty sure it's 2. But past that, if you Google, right, it'll say there's 5 basic senses. And then you can find other articles where there's 20 or 15 or 30. Right? There's not a different number. There's one number, there's one correct one. But that's speciality. That's people genuinely not knowing and saying, and go read the articles. I mean, they're goofy. It's like, only the delusional scientist is not educated enough to know about all of these 17 other senses. Right? Maybe there's 50 dimensions and 17 dimensions. Maybe there's 69 million of these senses. No. There's a basis. It's finite. There's a rank to it. What is it? Don't know. Thanks for watching From Rhythm to Algorithm, Part 35, Interactions and Intersections.